Hey everyone, CoolKid here. Something that I think is kind of underappreciated about Warframe is that it's a game that takes place in space, or more specifically, our own solar system. Unlike a lot of other sci-fi franchises that take place in distant star systems, Warframe being in our own solar neighborhood gives it the opportunity to do cool and creative fiction with celestial bodies that actually exist. This setting has allowed DE to bend the planets and dwarf planets of the star chart in really cool ways, and I think it's not talked about enough. So, in this series, I'm going to talk about the various locations we explore throughout the star chart, what they're like in real life, what they're like in Warframe, and what in-universe lore explains the differences. Despite this being a very inherently nerdy topic, I'm going to do my best to make this series as accessible as possible, so aside from some very basic science terminology, you won't need any pre-existing space knowledge for this series to make sense. At least that's how it'll work if I don't suck at my job. For our first episode, I think it's only right to explore Mercury, the closest planet to the Sun and the first of the terrestrial planets, those being the rocky innermost planets of Mercury, Venus, Earth, and Mars. While this is ultimately a Warframe video, I'm going to give a rundown of what Mercury is like in real life so you can have a solid basis to understand how Warframe differs from reality. Aside from the obvious stuff like the space ninjas and whatnot, Mercury is, like the rest of the planets, named after a Roman god, being Mercurius. He was associated with things like commerce, communication, travel, trickery, luck, and thieves, and he also served as both the messenger of the gods and a guide for souls who were entering the underworld. If you're more familiar with Greek mythology, Hermes is the analog for Mercury, as much of Roman mythology is just stealing. Much of what we know about Mercury was gathered over two NASA missions, those being Mariner 10 in 1974 and 75, and Messenger in 2008 up to 2015. Quick side note, Messenger might be the worst acronym I've ever seen. Look at this. It stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. And just, who structures an acronym like this? Regardless, something you might immediately notice is that we've only sent two missions to Mercury, and they were over 30 years apart. Despite it being fairly close to Earth, Mercury is incredibly difficult to explore due to its proximity to the Sun, which presents a lot of challenges with both the extreme temperature and the gravity of the Sun itself. For reference, Mercury is on average about 0.4 astronomical units from the Sun, with 1 astronomical unit being the distance between the Sun and the Earth. Because of the close proximity, any probes sent to the region have to be equipped with advanced heat resistance to survive, and lots of clever tricks have to be used to keep any would-be explorers from being pulled in by the Sun's gravity. The stories and logistics of both Mariner and Messenger are incredibly interesting, and I'll leave some resources in the description if you want to learn more about them, but the reason I bring them up in this video is because almost all of the real-life pictures I'm going to show you today are going to be from these two missions. I'm also going to be showing a lot of footage from the program's Space Engine to show off Mercury, including using an in-game texture pack that uses real images from Messenger. I'm also going to use Universe Sandbox a bit, but that's neither here nor there. So, onto the planet itself. Mercury is roughly 1/3 the size of Earth and has no natural satellites, so no moons or anything of that sort. I mentioned earlier that Mercury is about 2/5 of the distance between the Earth and the Sun, but you might have noticed I said on average. That's because Mercury has the most eccentric orbit of all the planets, meaning that its orbit is very elliptical and its actual distance from the Sun varies wildly at different points in its year. Here on Earth, seasons come from the planet tilting on its axis by about 23.5 degrees. On Mercury, though, seasons come from this wild variance in distance to the Sun, where it's just shy of 70 million kilometers at aphelion, which is its farthest point from the Sun, and 46 million kilometers at perihelion, which is its closest point to the Sun. As you might notice, that means Mercury is a whole 24 million kilometers closer to the Sun at its nearest point than its farthest, which is important for a lot of reasons. One of the big ones is that, because the distance varies so wildly, the Sun's gravity is more or less impactful on Mercury at different points in its orbit, because gravity increases in strength the closer two objects are to each other. This gravitational effect causes immense amounts of friction within the planet itself, and creates an effect called tidal heating, which keeps the planet's iron core molten, allowing it to form a weak magnetosphere. A magnetosphere is a large area around a given astronomical object that, for the purposes of most planets, serves to protect them from solar wind, which is a constant stream of charged particles that radiate outwards from the Sun. This magnetic field is only about 1.1% as strong as Earth's, but it's enough to protect the planet from the Sun's solar wind, which is something even Mars can't do. Now, as we're talking about the planet's orbit, you're probably wondering, what's a year like on Mercury? Well, that takes 88 days, which is actually part of why the planet is called Mercury, as it zips so quickly around the Sun that it was associated with its namesake speedy messenger god. Aside from the short year, the close proximity to the Sun also creates a very interesting gravitational effect called a spin-orbit resonance. Mercury's spin-orbit resonance is 3-2, which means that for every 3 times Mercury spins about its axis, it revolves around the Sun twice. To understand why this is significant, I need to explain that there are actually two different kinds of days in astronomy. The sidereal day, which is how long it takes a planet to complete one full rotation on its axis, and the solar day, which is measured from sunrise to sunrise. On Mercury, a sidereal day is about 58.65 Earth days, so it takes just shy of 59 days to fully rotate once. Because of that 3-2 spin-orbit resonance though, a single solar day takes 176 Earth days, or 2 whole Mercurian years. So for one Mercurian year, a single side of the planet will be in constant sunlight, and then for the next year, that side will be in constant darkness. This is because the planet is so close to the sun that the sun's gravity impacts its rotational speed, creating this spin-orbit resonance. This will come up a few other times in the series, primarily as it relates to moons, but it's very noteworthy for Mercury and will actually tie into some in-game lore later. So, now that we're done with the fundamentals of the planet's orbit, let's talk about geology. Because of its proximity to the sun, the daytime side of Mercury sits at a scorching 420 degrees Celsius on average, which is 790 degrees Fahrenheit for my fellow Americans. Or, Liberians or Canadians, if you're from there? For some added perspective, the sun is about 7 times brighter on Mercury than it is on Earth, which might help explain the heat. Because there's no atmosphere to distribute all this heat though, the nighttime side sits at an average of negative 170 degrees Celsius, or negative 270 Fahrenheit. It's important to note that Mercury has the lowest axial tilt of all planets, meaning it's not tilted on its axis almost at all, which causes craters at the poles of the planet to be in a state of permanent shadow. These poles sit at about negative 93 degrees Celsius, and there's even evidence that water ice is likely present in these craters. Speaking of craters, one of the most striking and immediately obvious features of Mercury is that it's absolutely covered in them, showing its history of meteorite impacts over tens of millions of years. These meteor impacts also create large mountain ranges, alongside many ridges and plains. With how long these craters have been around, we can pretty confidently say that Mercury hasn't been geologically active in a very long time, as planets like Earth have processes such as plate tectonics to renew surface material, which is very obviously not happening here. There are several areas that have been found to be volcanically active though, with many of them being directly within the many impact craters dotting the Mercurian landscape. There are also several hollows regions that we think formed from volatile elements sublimating off the surface, as well as from things like radioactive decay. Ancient lava flows have also been seen, which leads to another very interesting point. Early in its history, Mercury was likely covered in a magma ocean. We know this because the chemical composition of Mercury's surface is highly heterogeneous, which just means it's chemically varied. Scientists think that many of Mercury's geological features that can't be attributed to meteor impacts may be from the surface of the planet cooling faster than its interior, causing it to contract and crack. So, what is Mercury actually made of? Well, as far as we've analyzed, it's about 70% metallic compounds and 30% silicate, with a mostly silicate crust and mantle leading into a metallic inner and outer core of mostly iron. This core is estimated to be about 57% of Mercury's total volume, which is kinda nuts. For comparison, Earth's core is only about 17% of its total volume. The crust, or outermost layer of the planet, is estimated to be about 35 kilometers or 22 miles thick, with the mantle and crust region adding up to a combined 420 kilometers or 260 miles thick. Mercury is also the second densest of all the planets, at 5.427 grams per cubic centimeter, which is just a tad behind the densest planet in the solar system, that being Earth, at 5.515 grams per cubic centimeter. Because it's so dense, the surface gravity of Mercury is almost the same as Mars, despite being about 2/3 of Mars' size. This surface gravity is a bit over 1/3 of Earth's, being 3.7 meters per second squared versus Earth's 9.8 meters per second squared, which shakes out to roughly 38% of Earth's gravity. Mercury is very similar in size to a few other objects in the solar system, such as Ganymede, which is the largest moon of Jupiter, and Titan, which is the largest moon of Saturn. Despite the similar size, however, it's much more dense, meaning Mercury's surface gravity is much higher as the planet has much more mass. So, I mentioned earlier that Mercury has no atmosphere, but it does have something that's still very interesting, an exosphere. This is a thin and unstable layer of particles that is so loose that said particles don't even interact with each other. What do I mean by unstable? Well, the particles that make up the exosphere are constantly lost and replenished from various sources. Particles are carried away by solar wind or otherwise escape into space, while various processes renew those lost particles. The exosphere contains a lot of chemicals, like hydrogen, helium, oxygen, sodium, calcium, potassium, magnesium, and silicon. The presence of hydrogen and helium aren't super surprising, as those are likely deposited by the solar wind that blasts the planet, considering that the main things the sun is made of are hydrogen and helium. The other elements are interesting though, and we're not entirely sure how they get there, especially considering that many of them are metals. Radioactive decay from volatile compounds on the surface of the planet is likely a contributing factor, as well as the sublimation that formed the aforementioned hollows regions likely also creating material for the exosphere. The exosphere also contains water vapor, which was a big surprise for scientists, likely coming from the polar water ice I mentioned earlier. The amount of material emitted from the exosphere changes at different points throughout Mercury's year, but during its high points, Mercury has a visible tail in the night sky from Earth, which is really cool. So, that's all I wanted to cover about Mercury when it comes to real-life science. Note that this section is not at all comprehensive, and there is a lot of fascinating stuff to learn about this planet, but that's all that will be relevant to our discussion. I will leave resources in the description if you want to learn more, which I do highly recommend. To serve as our transition between fact and fiction, I want to talk about the various star chart mission nodes on Mercury and where they get their names. A lot of these are rooted in Latin, so be warned, my pronunciations aren't going to be great. The most important node to explain is Caloris, which is named after a region called the Caloris Planitia, notable because it's the site of a massive impact crater. The region has a diameter of a whopping 1,550 kilometers and is surrounded by a region of mountains called the Caloris Montes, which sit at around 2 kilometers tall. The name of the region comes from the Latin calor, meaning heat, which, aside from the obvious, comes from the fact that the sun is directly over the region for the entirety of the planet's time at perihelion. The crater at the center of the basin also contains plains of lava, which is rad as hell. The reason it's so important to explain this node's name first is because several other nodes are named after geological features that are also within this region. Speaking of, our next node is Pantheon, which is named after Pantheon Fossae, a region of radial troughs that lie within the Caloris Basin. The crater at the center of the region is named Apollodorus, which just so happens to be the name of another mission node. Interestingly enough, this crater likely isn't what created the surrounding region, instead seemingly being there out of pure coincidence. On the topic of craters, there are two more nodes named after craters on Mercury, Boethius and Tolstoy. Boethius is named after Roman politician and philosopher Anicius Manlius Severinus Boethius, fucking hell, who existed in the early Middle Ages and made several important contributions to history, such as being one of the main people who translated Greek literature into Latin and also being a leading Christian scholar in his era. Tolstoy is named after Leo Tolstoy, a Russian author best known for his book War and Peace, though he's made several other influential works and is regarded as one of the most important authors of all time. The Tolstoy crater itself also seems to have formed fairly early in Mercury's history, with the basin surrounding the crater being ancient. While not exactly a crater, the node Suissae is named after the Suissae Planitia, which is a large and relatively smooth plains region thought to have been created by material ejected from the Caloris impact. Suissae is also the Japanese word for Mercury, so that's also a likely origin for the node's name and my struggle to pronounce it. Moving on from the geological features, there are also many nodes on Mercury that take their names from mythology. The most obvious is Odin, which has a very interesting story. You see, the Romans associated the Norse god Odin with Mercury, which was done for an interesting political reason. When you're an empire like Rome and you go around conquering regions, it's pretty expedient to try and tell other cultures that their gods are actually your gods to make your own religion seem more legitimate. As such, Odin was associated with Mercury much like how Hermes was, as they shared some superficial traits such as associations with magic and knowledge, trickery and disguise, and traveling between realms. Next up is Terminus, which is named after the Roman god of landmarkers, which is another thing that the god Mercury is also connected to. Terminus is closely associated with land ownership, even having his own festival called Terminalia, which was celebrated by landowners every February 23rd. Yes, the Romans had a landlord deity. The node Lares is named after, well, the Lares, which were sort of local guardian deities who were said to watch over the things and events that took place within their domain. The last mythological node is actually Larunda Relay, as Larunda in Roman mythology was a water spirit who fell in love with Mercury. Her tongue was eventually cut out by Jupiter, king of the gods, after she revealed to his wife Juno that he had an affair with Juturna, the wife of the god Janus. Her story also says that she birthed the first of the Lares, though the details of that are, unpleasant. While not exactly mythological, the node Elion is a Hebrew name, which is associated with the Greek name Helios, meaning sun. In Hebrew, the name Elion also means things like supreme, highest, or uppermost, which seems to further describe Mercury's proximity to the sun. Our final node is M', which I don't really have any clear explanation for. My guess is that it stands for Mercury Prime, and it's named such as it's one of the first nodes we can play on, meaning that it's likely a very valuable region as it connects closely with the solar rail that links us to Mercury. Okay, now that all the nodes have been explained, I have one more node-related thing I want to bring up. You might notice that many of these nodes are very far apart, despite several being close to each other geographically in real life, like Pantheon and Apollodorus, for example. Some of the nodes even appear to take place on the surface of the planet itself, though this is not the case, as can be seen with several tiles that look out into space. I point this out to clarify two things. The names of the nodes are not accurate descriptions of where they take place geographically, and where the node is physically on the star chart does not mean the node actually takes place there. This will be important throughout the entire series, but I wanted to point it out now. So, getting into the representation of Mercury within Warframe, I want to start with the lore we get from its Codex fragment, which reads, Galleon fleets keep watch over the Grineer mining operations that penetrate Mercury's asteroid field. Cavernous rooms and twisting metal corridors mark where laborers have stripped the region for crucial resources, transforming the natural landscape to support Grineer occupancy. That's all well and good, but you might have noticed that all of my talk about Mercury earlier never mentioned an asteroid field. I even specifically mentioned that Mercury has no natural satellites, so where does this asteroid field come from? Well, while it's never explicitly stated, I do actually have a theory about it. This is not supported by a ton of direct evidence, but I think it makes sense, so let me explain. So, I mentioned earlier that Mercury is both very dense and made of a lot of metal, which means the planet would be very valuable to mine for minerals that can be turned into things like weapon and ship components. Issue is, Mercury is also incredibly hot or incredibly cold depending on which side you're on, meaning that establishing habitation on the planet itself is very difficult. As such, my theory is that the Grineer are using some kind of high-yield explosive to blow chunks of Mercury out into space, which can then be mined much more safely and manageably than if they were on the surface of the planet itself. When viewing Mercury in the star chart, you can even see constant flashes of orange and red, which may represent explosions from these bombardments tearing up the planet's surface, or maybe even loose material crashing back down from the asteroid field above. This theory does have its issues, absolutely, with one of the big ones being that the Codex entry uses the term natural landscape when describing the asteroid field. Thing is, the Codex entries do sometimes outright lie, which will become a bigger problem later in the series, but also means it's possible this descriptor isn't accurate when it comes to Mercury. This could also mean that the asteroid belt around Mercury formed through some other process, such as a massive meteorite impact, but there's just as little evidence for that as there is my own theory. I think it's a neat idea that makes some sense, even if there isn't a ton of direct evidence, so I wanted to include it. Alright, so aside from my crackpot theory, let's take a look at Mercury itself through its orbital skybox in the orbiter. The first thing you'll probably notice is that the planet is brown, which is also the case in the star chart, and is just not the color of the planet. The sun is also pretty dim and weirdly translucent for some reason, which is not really what you would expect from the planet that's closest to our host star. Mercury can also be seen rotating very quickly in this skybox, which shouldn't be the case considering its real-life sidereal day length of almost 59 Earth days. Most glaring, though, if you ask me at least, is that the aforementioned Mercurian asteroid field is entirely absent. On the bright side, we do have two whole galleons. This skybox really shows its age, but fortunately we do have a more up-to-date one that appears during the third act of the new War Quest. The sun seems to be too close to Mercury in this instance, but I think that it both conveys its proximity to the star better and is also just really cool visually, so I'm letting it slide on the grounds of rule of cool. I'm gonna be honest, things being too close to each other is going to be the #1 recurring issue in this series, so you're gonna have to get used to it. The planet is also actually the right color, being much closer to its natural gray. Most notably, though, is the existence of the asteroid field around the planet, which helps to visually represent what the Codex fragment told us. You can also see what looks like the sun's solar wind interacting with the exosphere and stripping away particles, which is a really neat touch. I really hope that at some point the normal orbiter skybox gets replaced with this one, or at least some variation of it, because it's both absolutely gorgeous and also does a much better job of conveying what the game's lore is trying to get at. So, now that we've established a few reasons why that asteroid field might be present, and what it looks like, let's talk about its contents. Mercury is made up of two tile sets, the Grineer Galleon and the Grineer Asteroid Base. Galleons are the Grineer's primary warships, and, as mentioned by the Codex fragment, are present to protect the mining operations present within the asteroids. These galleons pack massive arsenals and troop complements, and serve as both habitation and projections of Grineer power in orbit around the worlds that they control. The asteroid-based tileset takes place within the asteroids themselves, showing how the Grineer are stripping them of resources from the inside. These asteroids have been converted so that Grineer workers and soldiers can remain inside as the material is mined, with bunks and ventilation systems carved throughout the rock. With how slapdash everything looks, it's clear this arrangement is far from permanent, likely only lasting until the inhabited asteroid is picked clean. Many mining machines can be found throughout the tile set, which are used to chew through the rock in search of both additional resources and new room to establish habitation. Lava rivers can also be seen throughout the tile set, which may be waste rock that has been melted down to be discarded, minerals being refined or transported, or maybe even features of the asteroids themselves stemming from their violent ejection from Mercury. Large series of pipes and conveyors can be seen throughout the tile set as well, moving the large quantities of mined material for both refining and shipment. Now, one comment I want to make about this tile set is that I really think it should have some unique enemies. The Grineer here are just like their Galleon counterparts, but the purpose of an asteroid base is entirely different from a Galleon. I think it would be really cool if we had a Grineer subfaction of miners. Like the kind that mine rocks and minerals. As I was saying, It would be cool to combat Grineer that are equipped with mining tools and equipment, alongside their complement of marines that are there to protect them. We could even have cool idle animations of them mining or working like the Juno Corpus have, as well as unique armor to show how they're adapted to the conditions of working on the asteroid base. This is ultimately a pretty minor point, but as this tileset is up for a relight soon, I think it would go a long way in improving the immersion if DE took the extra step and gave this area its own sub-faction too. The last important thing I want to mention is the presence of the Infested, which are released by Dr. Tengus during the quest Once Awake and become a major presence in the region afterwards. They can be encountered on several nodes throughout the player's journey through Mercury, though I think it's interesting to question whether or not they can survive in the region permanently. The Infested are very weak to heat, and the intense solar energy in the Mercury region would probably bake them if they were outside an asteroid base or galleon. As such, it's entirely possible that they may not be able to survive without occupying the Grineer's existing structures, which would also severely limit their spread. Nothing in-game really addresses this question, I just think it's a fun idea to put forward. So, that's Warframe's approach to Mercury, a somewhat scientifically tenuous, but still compelling fictitious twist on the first of the solar system's planets. This might be surprising, but Mercury actually doesn't have that much to talk about compared to many of the other objects in this series, so while I had a ton of fun diving into what this location has to offer, we're barely scratching the surface of what this series is going to cover. Mercury is an old location that remains relatively unchanged after all these years, but newer locations with more recent lore and visuals do some incredibly cool stuff that I'm very excited to talk about. I also want to give another big shout out to Space Engine. It's a really awesome tool that I recommend you check out if you like this kind of stuff. If you would, let me know what you thought of this video in the comments. I am very interested in the feedback that I will receive, as this is so different from the other stuff I posted on my channel. Do also let me know what other theories or insights you might have, as this topic is brimming with potential for speculation and I think it's super fun to talk about. Beyond all that, I want to give a huge thank you to my YouTube members for helping to refund the cost of my Space Engine Pro license, and I want to thank you very much for watching. I hope you all enjoyed, and I'll see you all next time when we talk about Warframe's sweltering hellscape turned winter wonderland, Venus.